Welcome to the ArcGIS API for JavaScript session on building apps with Angular. I'm Andy Gupp from the ArcGIS API for JavaScript team, and I'm here with my colleague Eric Pates, and he's a developer from our professional services team. This is an advanced discussion about using the JavaScript API version 4.18 and greater with Angular 11. If you are joining us today and using JS API versions 4.17 and older, then you will need to use the ArcGIS Webpack plugin or Esri loader. We won't be covering those libraries in this session. We will be using the JS API's new ES modules that were just released at 4.18. Last thing before we get started. One of the great benefits of Angular is it's very powerful, and there's many different ways to do things. The coding patterns we're about to show may be one of several ways to implement certain functionality. They're intended to demonstrate concepts, to spark ideas, and to help you get a jump start on your projects. So here we go.
Okay, thanks, Andy. So when I was thinking about the sample code I would show for this presentation, I wanted it to be more substantial than a few simple code snippets showing how to add a layer or pan and zoom the map. There are plenty of samples and documentation on the JS API webpage that can help you get started. What I did was to create two projects which can be considered starter applications that can be forked on GitHub. The GitHub links are shown here so you can take a look as we go through the presentation. The first project stores state and services, which can be a solution for smaller applications, but does not scale very well when the number of components and services increase. What usually ends up happening is a large number of services are injected into a component just to access different parts of the application state. More services are injected, more subscribers are created, and the more complex the component and tests become. Tests become so complicated that developers may decide not to write tests, which can lead to more problems. This resistance then will slow down your ability to add new capability as time goes on. What is needed is a coding pattern that can scale as the project complexity increases. One way to achieve this is to use a state management package which provides a coding pattern that separates tasks into specific classes and functions. The second project demonstrates this by using a state management package called NgRX. I hope to show that this approach can scale more easily for medium to large scale applications. The major packages used to create the demo projects are shown here. There is not enough time to go into each in detail, so you can review the GitHub repos at your own pace. Obviously, we're going to use Angular as our JavaScript framework, and Angular material is used for UI elements like buttons, toolbars, lists, and icons. The Angular Flex layout is used for building an adaptive UI that can adjust as the width of the browser changes. It also has a list of directives that can be used to define the CSS for Flexbox without actually using the CSS directly. The Angular in-memory web API is used to simulate a REST API because I did not write one for this demo. We will be using the ArcGIS JS API version 4.18, which can now be installed like any NPM package. NgRX is used for state management in the second project, and we will show a few testing examples that use Jasmine with the create spy object for mocking services. Jasmine Marbles is used when writing tests for observables. It offers a compact syntax that can describe the state of an observable that can be used in a Jasmine expect. Lastly, the Karma code coverage will give you a nice report of what code is covered by tests and what code is not. So let's take a look at the demo application. I'm going to click refresh so you can see the application load. When the app loads, you can see some spinner animations showing that the map is loading and the bookmarks are loading on the left. Just for demo purposes, I put a 2-second delay in the service calls so that we can see the loading animation. If I resize the browser, the UI will adjust based on the screen width. When the browser width is below 950 pixels, the side nav will move from being next to the map to being on top of the map. The vertical toolbar on the left is hidden, and the navigation elements in the header will collapse into a hamburger menu that will appear in the top left. If I continue to reduce the width of the browser to below 600 pixels, the side nav will fill the whole width of the browser. I can close the side nav by clicking on the X, and I can use the hamburger button to open components. If I increase the width of the browser, the side nav will show on the left on top of the map again, and if I continue to increase the width, the side nav will be showed next to the map. And now we're back where we started. Lastly, I want to show you that the state of the map will be maintained if I navigate away from the map route and then back again. So let's pan and zoom the map to make changes to its state to something different from the initial state. Now I'll navigate to the home or the tools route using the header and then back to the map route. You can see the map is in the same state it was when we left the /map route, so that's pretty nice. I don't have enough time to show both projects in detail, so we'll have to focus on the second project. Before we jump into the code, let's take a look at a few slides that show the basics of the NgRX state management pattern. One aspect of using an approach like NgRX is that it isolates the component from the rest of the system. The typical pattern starts with the component. The component will dispatch an action which gets added to an actions queue. The component simply says, hey, I need something. It does not care how that something gets done or who does the work. Next, reducers listen to changes in the action queue and respond by modifying the state. The reducer's role is to update the state. It has access to any optional payload from the action and the current or old state. The final step is the selectors listen for changes in the state and make it available to the component as an observable. Now, the first thing you might notice is we never used the REST API to talk to the server. NgRX refers to making a call to the server as a side effect and offers an object in their API called effects to manage this workflow. Let's take a look and see how effects can change the workflow. Everything starts exactly the same by having the component dispatch an action which gets added to the actions queue just as before. Now the actions queue is being watched by an effect that you define. The effect will respond when a specific action is dispatched and then make a call to a service to do some work. The effect receives the results and then adds a new action to the actions queue. The final steps are the same as before. The reducer will update the state and the selectors will provide the updated state to the component in the form of an observable. An example of using an effect are fetching an array of items from the server. In our demo application, we have a bookmarks array that can be accessed by using a REST API. We start by dispatching an action called getBookmarks. The reducer will respond to this action by updating the working state so the component can show some kind of working animation like a spinner. The effect also responds to the same getBookmarks action and uses a service to get bookmarks from the server. Once the bookmarks are retrieved from the server, the effect will add a new action called getBookmarksCompleted to the actions queue, which will contain the bookmarks array. The reducer will respond to this new getBookmarksCompleted action by changing the state from working to finished and write the bookmarks array into the state. Finally, the selectors will provide the state change and the array of bookmarks to the component in the form of an observable. That was a very quick overview of the different actors that make up the NgRX pattern. Let's take a look at some of the code that leverages this pattern in our example application. If you're interested in the adaptive UI and the Angular Flex layout, then take a look at the header and map components. These two components use the Angular Flex layout package to hide and show visual elements as the width of the browser changes. I'm also using the Flex layout directives to define CSS Flexbox classes without using CSS directly. If you're interested in how this works, I have created a README in the second demo project that explains how I use the Flex layout, which you can see on the right side of the screen. You can review this README at your own pace. I do not have enough time to review all aspects of the application, so let's focus on the components and services used to manage the map. Before we start looking at components, reducers, and effects, we first have to define what our application state looks like and configure the store. Here's an interface called app.state, which has three read-only objects called map.state, bookmarks.state, and router-reducer.state. The map.state is an interface that defines all the properties required to track state changes for the map. For this demo, I am tracking what I call service status, the web map JSON document, any map view properties like the current extent of the map, and the side nav, which tracks if it's open and for which route path. The service status is a shared class I use to track the status of a service. It has four states defined as a string enumeration, which are loading, content, error, and empty. Loading means the service is currently busy. Content means that the service has finished and has content ready to be used. Error is when an error has occurred, and empty means the service successfully finished, but the results were empty. Typically, I use the empty state if the service is returning an array of objects. An example of that in this project is the array of bookmarks. The bookmark state is similar and contains a property for its service status and an array of bookmarks. The third property in the app state is called router reducer state. I did not write this interface as it comes with the NgRX package. It's used to store the state of the Angular router in the store. Here is the app-store module, which is where all of the NgRX store configuration is defined. There is a bit of syntax you have to get used to, but essentially this module registers any reducers and effects with the store and configures the router store and its serializer. The router store is provided by NgRX and is used to watch for changes in the Angular router and save those changes in the store. I use a similar approach to keep the state of the map view in sync with the store. We'll talk about that a little bit later. Now we have defined our application state and configured the store. Let's take a look at the map-view component. This component will dispatch the action that starts the process of creating the map. This component also has a viewChild reference to a DOM element with an ID of map-view div. We'll use this div when we construct our map view. Let's start by defining the constructor of the component and inject any dependencies that we need. As you can see, we are going to inject a reference to the store and a service I call map-factory, which we'll use to create the map in map-view. Now that we have the store injected into our component, we can use it to dispatch an action to start creating the map. Let's dispatch the getWebMap action from the ng on init. Remember that once the action is dispatched, the reducer and effects will be listening for the getWebMap action and do their part by talking to the server and modifying the state. Once they are finished, the state changes are provided to the component as an observable using an NgRX selector. Let's add an observable for the changes in the service status. Remember, the service status is a shared class that tracks if the state is loading, has content, or has an error. Now let's use an NgRX selector to select a service status from the application state. Let's take a moment and look at this line of code. We're using a selector that we called selectWebMapStatus to select the webmap status from the application state and provide an observable of service status. The selectWebMapStatus is not injected into the component as a dependency, but referenced at the top using an import statement. It is important to remember this when writing a unit test for the map-view component, because there's no way to isolate the selector from the component. Also notice that we are not directly subscribing to the service status observable because we are going to subscribe to it from the HTML. Let's take a quick look at that now. In the map-view component HTML, we are binding the service status observable to the service status property on a shared component I called status container. The pipe async syntax will automatically subscribe to the observable called service status, bind its service status value to the service status input property on a status container component. The pipe async syntax will also unsubscribe when needed. This component is used to display the working status, any errors that might occur, and when successful will simply show its content. Before we go any further, let's take a look at the map selectors used to create the service status observable. This is where you add any selectors needed for the map state. I have 5 already defined. The root selector called selectMap_state simply selects the whole map state from the app state. The other 4 selectors select other parts of the map state like webmap status, the web map, the map view properties extent, and the side nav open property. As our application grows, we can add new selectors for new properties in the state. Let's get back to the map view component. So far, we have injected the store, dispatched an action, and created a status observable. Now we need to create another observable for the web map and construct the map view. Let's use another selector called selectWebMap to get an observable of web map and subscribe to it. We are using the select web map selector to provide an observable of web map that we can subscribe to. We are also filtering out any instance where the web map is null or undefined. The initial state of the web map property is null or undefined before the service has fetched the web map JSON from the server. Now we have access to the web map JSON, which I call web map document. The next step is to construct the map and map view objects by using a service I created called map-factory. We make a call to a method called initialize map-view on map-factory and pass in a reference to the viewChild DOM element and the web map JSON object from the state. The map-factory is where the map and map-view are created and managed. Let's finish the map-view component, then we can take a look at the map-factory. Now there are a few items left to add to our map-view component before we are finished. First, we need to make sure that we unsubscribe from our web map observable, otherwise we will have a memory leak. Remember that the map-view component is tied to the /map route, so when the user navigates away from the /map route, the map-view component will be destroyed. If we do not unsubscribe from the observable, the component will not be completely destroyed and it will remain in memory as a memory leak. I usually use the take-until ArcGIS operator to make sure to unsubscribe from any observables when the component is destroyed. First, we need to add a private subject. Next, we need to define the ngOnDestroy method for the component and complete the subject. Lastly, we need to add a take-until ArcGIS operator between the select web map and the subscribe. Let's take a minute and look at this. When the component is destroyed, the ngOnDestroy will be called, which will write an empty value to the subject called ngOnSubscribe and then complete the subject. This will cause the take-until operator to fire, which will cause the web map observable to complete, and then a component will be successfully destroyed. The final step to finish our map view component is to let the map factory know the component is being destroyed. Since the JavaScript API map view requires a div element in its constructor, the map view will also get destroyed if the div element is destroyed. The map factory will remove the div element from the DOM and keep a reference to it. When the component is recreated, the map factory will not create a new DOM element, but use the one that was already created when the map view was first initialized. Let's call remove map view container on map factory in the ngOnDestroy of the component. That's it for the map view component. Let's take a look at the map factory and see how it's managing the map view. If your application has one and only one map, then in my opinion, the best place to store the state of the map view is in the map view. The map factory is not very complicated, and it does not recreate the map from objects stored in memory. It uses a simpler approach of removing the div element used to construct the map view from the DOM when the map view component is destroyed. The map factory service, shown here, follows what I call the initialize something get something pattern. We start with the initialize map view method, which we are calling from the ngOnInit of the map view component. There is also a get map view method that returns an observable of map view if needed. The initialize map view method uses a few private methods to create the div element, which I call map view container, the web map, and the map view. It also writes the map view to a map view subject so the map view can be accessed by other parts of the application if necessary. I have a service called navigation service that will access the map view by using the get map view method. The navigation service is used to keep the map state in sync with the store. The create map view container method will first check if the element ref is null or undefined. Next, we check if the map view container has already been created. If not, we create the div the first time. Lastly, we initialize the Angular renderer and use it to append the map view container div to the native element of the input ref. Next, we call the private method createWebMap, which will create the web map from the JSON document provided in the initialize map view method. If the map has already been created, then there is nothing to do. Now that our div and our map has been created, we create the map view. Again, check if the map view has already been created. If not, create a new map view using the map view container as the container and the web map as the map. Finally, we have the remove map view container method. This is where the map view container div is removed from the DOM before the map view component is destroyed. If we do not remove the div from the DOM, then the map view component will not be completely destroyed because the map factory, which is a singleton, has a reference to the div. This will cause a memory leak, and the only way to detect this mistake would be to use the memory profiler in the Chrome DevTools. That's it for the map factory. Let's take a look at the reducers and effects. Okay, here is our map reducer TypeScript file, which is where we will define our map reducer. The reducer is simply an exported function that is registered with the store. Let's start by adding our initial state. Since this is the map reducer, our initial state is an instance of map state, and we set the status property to content. Next, we need to use the createReducer function from NgRX to create our reducer. This is just a shell of a reducer where all we have defined is the initial state. We still need to add a case for each action this reducer is responsible for. Before we define a case for each action, let's add a public exported function that will be used to register our reducer in the Angular store module. Since we have defined our initial state, created a basic reducer with the createReducer function, and exported it using the exported function called map-reducer. Now let's define a case for each action that affects the map state. So here we're using the NgRX's on syntax to define a case for each action. Now the state is not being modified yet because each case simply returns the current state. We need to modify the state in a specific way for each case. Let's start with the getWebMap action. If you remember, the map-view component dispatches the getWebMap action, which will change the service status to working. Let's add a function that will update the service status property. Now take a look at this function. It accepts the map state, a service status type, and an optional error, and returns the map state. This function uses the object spread syntax from TypeScript to modify the map state without mutating the state. The object spread essentially merges the current state object with a second object that has a status property. The status property in the state is overwritten in the new state object and then returned. The state is never directly modified. It's very important that any state modifications made by the reducer does not mutate the state. This is an important topic that you'll have to understand if you're going to use NgRX. For example, if your state contains an array of items and you need to remove one of the items, you cannot use splice directly on the array because the splice function will mutate the array. You must use the filter function and replace the array in the state with the result of calling the filter function. Now let's use the update service status function in our reducer for the getWebMap action. Let's take a look at one more function that will modify the state for the getWebMap completed action. This function is called addWebMap.state. It accepts a map state and the web map and returns the map state. It uses the spread syntax to update the status and web map properties into a new state object and returns it. This is where the service status is set back to content and the web map is written to the state. Let's use the addWebMap.state function in our reducer for the getWebMap completed action. There are obviously other functions for other map actions that you can review in the GitHub repo. Let's move on to the effect. The effects are, in my opinion, the most complicated part of the NgRX pattern. They rely heavily on various ArcGIS operators that are used to modify observables. If you are not familiar with the ArcGIS operators, I suggest you spend some time reviewing the documentation. Here is our map effect TypeScript file where we will define any effects that we need. I have already created the map effects class, added the injectable decorator, and injected any dependencies needed in the constructor. I've also started to create the effect by using the createEffect method from NgRX. The result of an effect method is an observable. This observable is created by starting with the NgRX actions observable. We'll use various ArcGIS operators to transform the observable. The first operator we're going to use is called ofType, which actually comes from NgRX. It acts as a filter against the observable stream of actions. Let's add the ofType operator to our effect, which will filter out only those actions that are of type getWebMap. The next part is optional based on the requirements of your effect. We will use the withLatestFrom operator and the selectMap_state selector to get the current map state from the store and pass it on to the next operator. The last operator we're going to use is mergeMap. There are several similar operators to mergeMap called switchMap, concatMap, and flatMap. They all perform similar functions, so picking the correct one for your situation requires a strong understanding of these operators. It is important that you understand the difference so you can choose the correct operator for your needs. Let's add the mergeMap operator to our effect. Let's take a look at this code. The mergeMap operator is passed an instance of the current map state. It will check if the web map on map state is not null or undefined. If it is defined, it will return the getWebMapCompleted action with the web map as its payload. This is why the withLatestFrom operator is optional. If you don't mind having your effect fetch data from the server each time, then there is no need to get the current map state and check if the web map is defined. Adding this step will short-circuit the effect and prevent it from talking to the server when the web map has already been received. If the web map is null or undefined, this must be the first time the effect is reacting to the getWebMap action. In that case, we must get the web map from the server using the getWebMap method on the map service. If the service is successful, then we return an instance of the getWebMapCompleted action with the webmap JSON document as its payload. If there is an error, then we return an instance of getWebMapError action where the error is the payload. The effects can be complicated and require a strong understanding of the ArcGIS operators. It is also important to note that the effect has isolated the map service from the rest of the application. Changes to the map service will not affect any components because they do not directly interact with the service. If we take a quick look at the map service, we can see it is very simple. There is no stored state or data and no need to handle any success or error cases because all of that is taken care of in the effect. The last point to mention is our effect does not take into account the case where getWebMap has been called a second time, but the map service is still fetching the web map for the first request. This is the case where we want to short-circuit the effect, but not when the web map is null or undefined, but when the service status is loading. I have an example of this in the bookmark effect. If you're interested, you can review the code on the GitHub repo. That's it for the map effect. Let's move on to testing. Let's take a look at writing a test for the map-view component. I have already defined the describe for the test, created variables for the map-view component and the component fixture, and a mock for the store and the map factory because they are the injected dependencies. I also have an initial state object defined and the before each sections. Let's start by using the Jasmine createSPY method to initialize the mock map factory. Let's take a quick look at the createSPY method. It has a few overloads, but the one we are using here accepts two parameters. The first is what they call the base name, which we will set to the name of the variable. The second parameter is an array of method names that we'll need to mock for our test. We will need to add a string for the initialize map-view and the remove map-view container methods. Next, we need to define our testbed configuration for the map-view component. This is a typical testbed configuration when testing an Angular component, with the addition of the provide mock store in the providers array. The provide mock store comes from NgRX and is used to mock the store with any state you need. In this case, it's initialized using the initial state object. Lastly, we'll use the inject method on testbed to get a reference to the mock store. Next, let's define a test to make sure the service status is initialized correctly when the map-view component is initialized. The first thing we need to do in our test is define the structure of the state of the store. We need to use the setState method on the mock store object to define the state needed for this test. This initializes a status property on map.state to be loading, which will simulate the state that occurs when the map service is fetching the web map from the server. The next step is to call detect changes on the component fixture, which will start the component's lifecycle and call ng-on-init of the map-view component. The last step for this test is to define the expected service status observable and add an expect. The expected object is defined using the Jasmine Marble syntax. This describes an observable with one value that is of type service status, where its type property is set to loading. Finally, we expect the service status observable on the map-view component has one item in the service stream of type service status with the type set to loading. Let's add a second test to make sure the getWebMap action has been dispatched and the initialize map-view method on map-factory has been called with the correct parameters. First, we need to use the Jasmine spy-on method to watch when the dispatch method is called on the store. Next, we need to define the state in the store when the map has successfully finished loading. Now add detect changes to begin the component lifecycle. And finally, let's add our expects. The first expect makes sure that the initialize map-view method has been called one time. The second expects makes sure that the dispatch method on the store has been called with the getWebMap action. Now let's run the test with the watch and code coverage flags. The code coverage flag will create a report of the code that is covered and not covered by tests. When the tests are finished, we will review the code coverage report by looking for the coverage folder in the project and then opening the index.html file to see the report. Okay, here is our Karma report. Here's our two tests showing that they've successfully completed. Let's go look at the project files and look for the coverage folder. In here you'll see an index.html file, which we'll add to the browser. Here's the Karma code coverage report. We'll look for the map-view folder. Here's our map-view component. We're showing a 92% code coverage. If you scroll down a little bit, you see that we've got this red text here showing that we didn't have a test for the refresh method. So this can show you where, at a minimum, where you have to add more tests. That's it for testing. Let's move on. Okay, let's talk about the navigation service, because that is where the state of the map is kept in sync with the store. Now, I modeled this after what NgRX is already doing for their router store, which is used to keep the state of the Angular router in sync with the store. The code is available on GitHub if you want to review it. There are two cases that we must handle. The first is when the user directly interacts with the map and alters its extent. This is simply when the user pans and zooms the map. The second case is when the extent of the map needs to be altered by some other component. An example of that would be the bookmarks component needing to zoom the map to the extent of a specific bookmark. This is done by dispatching an action I called navigation request. On the screen, you will see the navigation service. We have a few private variables defined for the map view, a subject of map view properties, and a Boolean. The map view properties is a class I created that holds the extent, center, and zoom level of the map view. I have a subject of map view properties because when the extent of the map view changes, it can change very quickly, so we will use a debounce method on the subject to slow that down. The dispatch triggered by map Boolean will track if the extent is being triggered by the map or an external action from a component. The constructor has the store and the map factory injected. Since the map factory is where the map view is being maintained, we'll use it to get a reference to the map view. Let's add that now. When we get a reference to the map view from the map factory, we need to start watching when the extent changes. This is done in the initializeWatch method. Here we can see that every time the extent property on map-view changes, we write a new instance of the map-view properties class into the map-view properties subject stream. Next, we need to initialize the map-view properties subject and subscribe to it. Let's take a quick look at this code. I'm using the debounce time ArcGIS operator to slow down the stream so that it only emits a value every 150 milliseconds. Next, we are calling a method called dispatchMapAction that will dispatch the update map-view properties action with the map-view properties as its payload. Then we need to make sure the dispatch triggered by map Boolean is set to false. Let's add the dispatchMapAction method now. This simple method sets the dispatch triggered by map Boolean to true, dispatches the action, and sets the Boolean back to false. I'm using a try finally here to ensure that the Boolean is always set back to false. So far we have enough code to handle the case where the user alters the extent of the map by interacting with the map directly. When the extent of the map view changes, the update map view properties action is dispatched and the map reducer will modify the state in the store. Now we need to handle the case where the extent of the map is changed from another component. In the bookmarks component, it will dispatch a different action called navigation request. Now, the goTo method on map-view needs to be called as a result of dispatching this action. So first, let's add a goTo method to the navigation service. This method can accept a target that describes a zoom level, an extent, or a point. Now, how does dispatching the navigation request action call goTo? That happens in the map effect. You can see here we are watching for the navigation request action in another effect and then calling goTo on the navigation service. Also notice the dispatch false at the end of the effect. This tells the effect to not dispatch another action. Let's get back to the navigation service. The last case we need to consider is when the update map view properties action is dispatched directly. Right now this is only happening from the Redux plugin for the Chrome DevTools, which I will show a little bit later. For now, let's add the last of the code. First, we need to watch for changes in the map view properties extent from the state using a selector. Finally, add the navigate target from dispatch method. At this point, you might be thinking, this is way too complicated, or I might have lost you. Well, it is complicated, and I'll admit this feels a little hot-wired. A better approach might be to create an Angular module, just like NgRX does for their router store module, that would watch for changes in the map view extent and update the state in the store. If a component like bookmarks needs to modify the extent of the map, we could inject the map factory to get access to the map view, Or we could inject the navigation service and use its goto method, which would create a separation between the component and the map view. Either way, we can call the goto method directly to navigate the map. This is how NgRX recommends navigating the router. Initially, they had actions to dispatch, but now they suggest calling the navigate methods directly on the router. This could eliminate the need for the navigation request action. Well, that's all for the navigation service. Let's move on. The last thing I want to show is how to view the state at runtime using a Chrome plugin called Redux. Here you can see the DevTools on the left and the app running on the right. Notice the tab called Redux in the DevTools between elements and sources. Let's refresh the app and you can see all the actions being dispatched in real time. The first two actions are the store initializing itself, and then there are a few actions from the router store because we have technically navigated the /map route. Next, you can see the get web map and get bookmark actions being dispatched. If I select the get web map action, you can see the state in various ways on the right. I like to see the raw state, so let's pick those options now. Here is a JSON object that represents the state at the moment the get web map action was dispatched. Here you can see the status property on the map state is set to loading. We can inspect the state at any time for each action being dispatched. If we select the get web map completed action, we can see that the web map has been defined in the state. If we select the last action that was dispatched, called update map-view properties, we can see the current extent of the map. Let's collapse other parts of the state that are not related to this action. Here you can see the map-view properties object that contains the current center of the map, the zoom level, and the extent. If I pan and zoom the map, you will see more update map-view property actions being dispatched. I can even change the extent of the map by using one of the bookmarks. Lastly, I can hover over the actions in the list and pick the jump button to alter the state of the application to the state for that action. Remember that the state of the map is kept in sync with the store using the navigation service. I have also enabled GitHub discussions on both repos in case there are comments and questions that technically are not an issue. Though I hope this has given you a glimpse of how we can use a state management package like NgRX with the JavaScript API.
Thanks, Eric. Now I'm going to wrap things up. We really appreciated you attending our session, and we hope you enjoyed it. Here are some important links, and if this is during the live presentation or the final recording, go ahead and take a screenshot now, and we'll also post these into the chat session. And here are some interesting links if you want to research these topics further after the Dev Summit. And I'll go ahead and pause before the final slide. Last but not least, if you have follow-up questions, please feel free to reach out to us. Thanks again, and have a great conference. All right. Thanks everybody for attending, and we're now in the Q&A section of this. This is live. I'm here with my co-presenter, Eric, and we're going to be going through as many questions as we can. If we don't cover your question, please feel free to go over to the Ask the Experts forum and the web development channel, and we'll try and answer your questions over there. Also note that as we on our management panel selected a question has been answered, it's going to go ahead and disappear, and it'll be archived so you won't see it any longer. So with that, I'll jump into the first question. Do I need to use a state management package? And I'll pass that one over to Eric.
Technically, the answer is no. I mean, many people write Angular apps without state management, and I wouldn't even recommend trying to use one unless your application is large to medium in size. I've built a pretty large app without one, and it's been successful. So this is really up to the developer.
All right, so question number 2 is talking about using ngZone, and the samples over on JS API resources for the 418 samples, they're using ngZone, and what's the benefits of doing this? It's almost a topic in itself that we don't have time to cover in much detail. I can tell you for the 419 release, which is coming in just a few weeks, I removed the ngZone code to make the Angular sample more of a basic example. And it really has to do with the performance of your application and what you're doing within your application. Like if you have a table with a lot of rows, for example, you probably want to run that in ngZone and outside of your main app and away from the code that the map is running in order to get the best performance out of your application. My recommendation is to do a search on ngZone and read as many articles as you can. Do performance testing if you want to use it for putting the map inside the zone, and see what works best for you based on your particular requirements. So I'm going to go to the next question. I believe this session was supposed to be for Angular, but I see most of the attention was related to ArcGIS. Can you please provide more information about Angular? And I'm going to pass this over to Eric.
I don't think they meant RxJS. I think they meant NgRX. And yes, it was meant to be an intermediate to an advanced topic about something Angular related. It was definitely an Angular project, Angular, I think 11. And there is the other GitHub link. I created 2 projects essentially that are almost identical. The one that the presentation focused on was with NgRX, and the other one, which is just referenced on the first slide, was without NgRX. It was a more standard architecture. So if you want, you could review that. It's a framework of how to put the map in there and what are the things you have to do to get it up and running in Angular 9 or Angular with JavaScript 4.18. So.
All right, and we had a few questions about change detection. And Eric, do you want to go ahead and take this question?
For this project, actually either project that I posted for this presentation, I did not do anything special with zone or change detection. It's just standard out of the box Angular. So that's it.
The next question is about the Esri design system. Is there going to be documentation or samples using it for Angular? And the person who wrote this has used Angular material and calcite web components in the past. The short answer is no, we don't currently plan to include framework-specific documentation. For our ES modules, we try to be as platform agnostic as possible. In other words, we support as many JavaScript frameworks as possible: React, Vue, Angular, Ember, Vite, fill in the blank for your favorite framework. I'll go ahead and pass this on to the team for discussion, but the short-term answer is going to be no, not at the moment. Excuse me. The next question is, are there any configuration changes I need to apply to my project to get the JS API to work with Angular? And Eric may also have something to add to this. The short answer is no. Now at 4.18, there was a configuration for the assets, and those are images and WASM and a few other items. You will not have to do that for 4.19. At 4.19, the assets are pulled down via CDN. So if you are already using the assets or assets path for local reference to the assets, you can keep that. If you're doing a brand new installation, you can just install the modules and the assets should work just automatically.
A new question came in that went to the top. So Don't dismiss the wrong one.
Did you have anything to add on the configuration?
The only thing I would add is on both of my GitHub repos, the main README has the 3 or 4 steps that I went through to get the 4.1.8 API to work with Angular 11. So.
Right, and so you npm install the assets. You'll need to configure your CSS, of course.
Yeah,
and
I
then,
use the there's a tilde syntax you can use where it would webpack the main CSS from the Esri API, and then you have to do the Angular JSON configuration changes for the assets, and then the assets path itself.
All right, so moving on, since at 15 till is when the end of this session is for Q&A. There's a couple of questions here related to hybrid. We have a hybrid application with AngularJS and Angular 6. We can't yet migrate to Angular 11. We will do so soon. Which version would we start at? At 4.18, I get some errors with cyclic dependencies. Without knowing what those cyclic dependency issues are, we always recommend upgrading to the latest version, and that'll be 4.19 here in a couple weeks. And you can certainly post questions to the github.com/Esri JS API -resources repo, or open up a tech support ticket. If those cyclic dependencies are related to Angular 11, we'd like to get to the bottom of that. Also be advised, Angular 12 is coming out in May. So if you're looking to run on the latest, there's more changes coming down the pike for Angular. The next question is related to a hybrid, not a hybrid deployment like Cordova or Ionic, but I think they're talking about combining Angular 9 and require.js. This presentation has been about our ES modules. The AMD modules is a completely separate approach. There is a repo under github.com/Esri that talks about how to use the AMD modules with Angular. And if you go to github.com/Esri and search for Angular, it's Angular-CLI-Esri-map, and that'll show you some examples of how to work with the AMD modules. I believe we have posted the link for the sample code.
I replied to that question, yeah.
Yep, so I'm gonna go ahead and leave that one up. The next question by Nigel was, do we still, I know these move around, do we still need to use the ArcGIS Webpack plugin at 4.18 plus? At 4.18 plus, the Webpack plugin is optional. At 4.18, it will help you with the copying of the assets. And there's also some other, some other small performance enhancements, but it is optional at 4.18 plus. The next question is, if you show the map in multiple pages, how would you store the map to minimize the loading times? Eric, do you want to tackle that one?
Sure, I'm assuming he means within the same browser tab, multiple subtabs of some kind. I would not recommend doing what we did in the presentation, because technically the map is still in memory. So if you have many maps, say on a tab control, you could run into a memory problem, I would think. One alternative I thought about at the beginning of putting all this together was the web map is technically a JSON, can be represented as a JSON object. So in theory, you should be able to store that JSON object in state or in a service somewhere. And then when you had to reconstitute the map, you could just reconstitute it from that JSON. That would probably be much more memory performant. Hopefully that answers that question.
And I'll just add one quick note to that is there is a maximum number of WebGL contexts. So can't remember what that is off the top of my head. I think it's 12. Don't quote me on that. That's just something to keep in mind. The next question is Karma important for our performance app? Can I pass it?
I can take that. I wouldn't, Karma doesn't have anything to do with your app performance loading time. Karma is the testing framework. I would recommend everybody write as many tests as possible. Test that's covered is test that's good. Tests give you the confidence to change things over time and make sure you don't break things that were working previously, but it's technically not required. You can pass it if you want to, but I would not recommend it. And I don't see how Karma has anything to do with app performance. So.
All right, we got a question about E2E examples with JS API and Angular. We don't have any in the JS API resources repo. Eric, are you aware of any?
I'm not. I have written a few what I would call integration tests with Karma, and really all that means is typically when I write a test for a component or service, that it's only testing that component or that service. But sometimes you can write tests for components that leverage the nested components that may be within it, because sometimes the interaction between components and subcomponents is something you want to test. But I don't believe that's really what they mean by E2E. We have experimented with something called Selenium, which would be a way to do another form of end-to-end testing. It's like a scripting language that you can do to test as if the user's clicking buttons and interacting with your website. That would be more of an end-to-end or integration test because it's actually running the app. But I don't have any E2E examples at this time. So.
Let's see, is IE11 supported? I still have customers running IE11. IE11 is no longer supported as of the 4.18 API. So if you do have customers that need that, you'll have to stay with a version of the API that's previous to that. Do we have any custom widget samples in Angular? This has come up a number of times. The short answer is no. It's something that we're working on, and we're well aware of it. There's also, as part of that, we're working on internationalization. I know there's a lot of international listeners on our session, so there's a lot of things going on behind the scenes. We hope to have one for the 4.20 release, which is in the July timeframe. And hopefully we'll have something for you by then. And the next question is the Redux is the Redux plugin for the Chrome developer tools available for Edge Chromium?
It is now. Initially, it wasn't. When I started looking at this, it was not in the Edge extension store, but it is now. And even if you do run across a situation like that, that's available for Chrome and not Edge, Edge can load the Chrome extensions, so it shouldn't be a problem either way.
Right, and this is probably close to our last question here as we start to wrap things up. This is an expansion on the calcite components. Will, thank you for the clarification, and I will talk to the team and we'll see if there's any documentation that needs to be done to help you out. We'll try and get it out there for the next doc iteration. And we have one last question. When writing tests, where is the line in terms of testing things that Esri.js API does versus our business logic? And Eric, we have maybe a minute left.
Okay, I'll be quick. So you don't want to worry about testing anything other than the stuff that you write. So you don't need to worry about testing any third-party APIs, our API or anyone else's. I can understand how it might be difficult because I don't think you can actually inject like a query service into a component. So what I've usually done in those situations is I've written my own query service or query service factory or some factory object that wraps something from the Esri API. And then when I'm testing my component, I can mock that wrapper class. And then I don't test, the wrapper class is really just one-line pass-throughs for methods. They're so simple, you don't have to test them. So that gives you a separation between our API and your code. So.
All right, well, thanks everybody for attending. We appreciate it. If you didn't get your questions answered, please check us out over on the Ask for the Experts forum under the Web Developers channel. Thanks again.
Thanks, everybody.